Hello friends, welcome to our channel, that is a Hariharan channel, Hariharan Express channel. Again another problem. Today also another problem I will solve. The problem also similar concept, but some additional concept also there. Okay, now I will see that what is the problems. So that the hardware that implements the following statement include the logic gates for the control function and a block diagram for the binary counter with a count enable input. Here you see very simple statement is mentioned, that is x, y, t0 control function is defined in this way: x, y, t0 plus t1 plus y dash t2. These control functions are defined in this way. Number of control variables, okay, with t0, t1 and t2. If this is true, then the particular content will be increased through binary counter. That means AR is equal to AR plus 1, increment of that AR value. Address register content will be increased. Okay, so this is the basic concept. With the help of some logic gates for control functions and some block diagram, we have to design with the help of binary counter. Okay, so how it will design, I will show you. You can find out what are the concept, what are the basic requirement to draw this block diagram. We will see very simple way. Here you see three variables, control variables will be consider, that is x, y, t0. Again here y dash t2 means y complement t2. So here whenever this particular term x, y, t0 will consider, here we will consider only AND gate. AND gate contains three variables. Next, here is y complement t2, another AND gate will consider, and t complement is considered from that y. We will see that how it will design. Again these three terms, this one turn, this one another turn, this one another turn. These three terms also combined, okay, and connect and give in the inputs to the OR gate. Okay, one OR gate will consider, that OR gate contains the inputs from this AND gate. This is simple T1, another is another AND gate. Okay, whenever that OR gate will be true or this control function is true, then the counter, binary counter, will consider or will take for design, which is enable, and it count, and it count means it is that is increasing its address register. Okay, so this basic concept we will design through certain block diagram. Now we will see, we will draw that block diagram for this particular statement. Okay, now we see how we will design this. See here, first of all you see we have to consider, you see how to design. First of all you see x, y, t0, that means one AND gate will consider based on the three inputs x, y, t0. Another AND gate will consider, that is a complement of y and t2. That is most important. After that we will consider the two inputs, this one for OR gate. Now we see very simple way, I will show you. Now one AND gate will consider here. Okay, AND gate, very simple way, AND gate will consider. How many inputs? AND gate, for AND gates, how many inputs? You see x, y, t0. So one part is x, another part is y, another part is t0. X, here is y, another part is t0. Okay, these three variables, control variables, will consider. Another is another AND variable also, AND logic gate will consider for this y complement t2. Here you see already y is there, so we just connect through complement. Another AND gate will consider also here. You see very simple way, this is AND gate. One part is y complement, one part is y complement, another part is t2. So here whenever consider y complement, if it is go directly, there is no problem. Now we consider that is y complement with the help of that is inverter. Okay, we can consider that is inverter. Then one data consider here, that is a y complement. Here is a that is a y complement. Another data is required. What is another data? That is a T2. You see, very simple way. It is a T2. One is a y complement, another is a T2. So that T2 also we will consider here. Here is a T2. Okay, y complement and a T2. So one data we can get from this logic, that is what AND gate. Another data come from this another term y complement T2, and another is, you see, we have already designed for this with AND gate for this, AND gate for this. Again we will combine through what OR gate with T1 data. Okay. Now we see, we shall just draw one OR gate. Very simple OR gate. We have to draw it. Then one data from here, another data, that is T1 data. Another data is T1 data, that is you can also consider here. Another data also consider here. Okay. These three data again combined into the OR gate. Okay. These are the input. Actually these are output, but that output consider as a input to this OR gate. Okay. Now we see here, this, if this is true, then what happens here? Very simple way it is mentioned. You see, very simple way. What is mentioned? Include the logic gates for the control function. This is the control function, and a block diagram for the binary counter. That connection, that output of the control function, it connect to the binary counter. That means n binary counter we will consider. Okay. Now we see the n binary counter we will consider here. N bit binary. We can write here n bit. Okay. N bit binary counter. Binary counter. Okay. We can design in this manner. Okay. Binary counter. And here you see we have designed this binary counter. It is connected to the binary counter. Here what happens? It count. Okay. Count what are the data. What are the data? It count. It will be enable. It will be enable and count. At what time count? Whenever there is a clock falls. We can mention one clock. Clock pulse wise it will count. You see, here question is address register is increasing or binary counter is increasing it address register with a count enable input. Okay. Whenever this particular count enable or this particular active it is enable, then automatically binary counter is counting number of times. Okay. Here very simple way, count whenever it is enable, count the n bit binary counter. Automatically the address register data it will increase, count the number of times. Okay. This is the basic concept whenever we design of a particular this problem. The problem is very simple. It is defined. It has control function having three number of control variables like x, y, t0 and t1 and t2, and whenever this control function is defined either true or false, if this control function is satisfied or enabled, then it will increase the AR value. Okay, the content of AR will be increased automatically. It will increase through binary counter because the question is given. It is with the help of binary counter, means n bit binary counter we have to consider. Then it will increase the address register. In that case, n bit binary counter we will consider this address register. Whatever the register will consider, automatically its content will be increase. That is our motto. Here is n binary counter will write inside that n binary counter AR register is there. So automatically it will count its content of registers, AR register. Okay, so this is the basic design or block diagram with the help of a binary counter and with the help of a count enable inputs. Okay, count enable inputs. Okay, like this is a count enable inputs. Automatically this binary counter count the number of content of the register data. Okay, so thank you very much. Thanks to all to watch my videos. Most of the time I will try to solve different problems. Okay, as per the different model or different design of logic circuit diagram or combinational circuit diagram or any kind of circuit diagram whenever it is necessary, with the help of memory or with the help of register, whenever it is necessary we will consider and design accordingly. Different problems we will solve through my videos. So I think all of you understand, all of you enjoy to see these videos. Okay, thank you to all, and please subscribe my channel if you like, and if you want to give some comment, you also give some comments to improve my channel. Okay, thanks to all. Thank you.